Okay, we'll get started. Hi everyone, welcome back to second half of the semester. You guys had a good break?
No. Yes.
Some say yes, some say no. So, yes. Any questions about anything about the content so far? So I hope everyone's refreshed and then ready for the second half. Okay. So here's the potential assessment question. So this part we want to focus on why adding parameters would help with alterability. I'll let you think about it. Like what benefits is it will we have if we have parameters with methods? I think we kind of know from before the break that if we have parameters, the advice that's been given to us about parameters and functions, right? How it affects comprehensibility. But this question is about how if we have more parameters, how it affect alterability of our design. Here's the agenda. So after break, so we know that some of you wanted in-person help. So what we decided is that Lemise will be taking over the drop-in sessions. So the drop-in sessions now will be on Thursdays, 10 to 11. You can find Lemise in her office in 303S571. So we will not have the online drop-in session on Fridays. So please take note that if you have any questions, if you want to ask in person, you can find Lemise on Thursdays, 10 to 11, starting from this week. You can also find me in my office when my door is open. Okay, questions? So exciting that we have assignment 3 now available to you all. Yay! Who's looking forward to work on more color game?
I don't know.
You don't know? Yes, so again, same procedure. So assignment 3 is now available on Canvas. Please accept the assignment early so that you get the starter code. I don't know what happened with assignment 2 last time. I'm not sure why. I think there was a glitch with the GitHub Classroom. And so this second half of the course, we're going to look at alterability mostly. So we're looking at some of the advices that's been given to us about design patterns and solid principles and how these advice would help us with alterability, essentially. So here's a quick overview of assignment 3. So this time around, we want you to apply 2 design patterns to this assignment using the command pattern and memento patterns. So we're going to look at command pattern tomorrow. For the momentum, you'll need to do your own research around how to apply memento pattern. But we want you to basically add the function features of new game and save and load the game using the 2 design patterns. Okay. And we also want you to briefly explain, again, just like with assignment 1 and 2, you're going to fill a spreadsheet of how you use the patterns. And then you might need to justify if you move away from any of the maintainability advice that we've been talking about in the report. If you follow the advice, then you don't need to fill that part. But have a read through, look at the details. Everything's on Canvas now, I believe. Also, there is a short video by Ewan around bad design patterns. Please also have a look at that video before starting your assignment. It's due in 2 weeks' time, 27th of September, Friday. Questions?
Not yet.
Pardon? Sorry?
Not yet.
Not yet?
Can we extend?
Can we extend the assignment? Isn't it a bit too early? It's only the first day of week 7. Come on. I'll think about it, but...
Extend the assignment.
Pardon?
Why do we have an assignment on the first day of the semester?
Why do you have the assignment on the first day? At least I didn't give you assignment during your break. Yes, so this while we like to keep the momentum going, so the goal is that we want you to think about the design patterns, and again, another process of improving your implementation of color. And yes, we need some way to assess you. So,
Can you briefly explain that pattern?
command. So we'll look at command pattern tomorrow. Tomorrow we'll talk about command pattern. Okay. I know it's today the first lecture for you guys. Okay. So we'll chill a bit. Okay. So remembering our alterability. See, I feel very excited seeing you guys. So do you feel the same? Like it's the lecture coming back. So so with alterability, so remembering back from before the semester break, we had the three definitions, three attributes of the sub-attributes of maintainability, and one of them is alterability. And we think about alterability, like naturally we think about, okay, so if looking at our existing code, if there are fewer places that we need to change, then that means that our implementation is more alterable, right? And that means that if there's less code that need to change, that means that there are less places we need to change, and therefore it's less likely less mistakes we might make. So thinking about alterability, what we would like to focus on is that we want to have fewer places that we need to deal with that change, so that's more efficient, so it's faster, right? So in terms of time, if we have fewer places, then maybe it's faster for us to make the change, and also that means that it's fewer opportunities for us to make a mistake. So that's more effective. So that's the intuition for alterability. So when we look at alterability, remembering back from when we talk about alterability before the semester break, we look at the different change cases, right? We look at how much impact this change case could be to our design. So when we assess the alterability of the design, we should think about that because the design does not change, right? So the alterability should not change. But we also have different change cases that we could have for this particular design. And for example, if one change case is large, for example, going back to our noughts and crosses example, if I want to change a mark from uppercase X to lowercase x, this change case is small compared to if I want to change the noughts and crosses from a console application to GUI application. So that's large because if I introduce a GUI application, it means that it's more likely that I have many places I need to change my code, right? So there are many changes that I need to make. However, it doesn't mean that my alterability of design is poor because of that change case. So when we assess the alterability of the design, we need to look at the overall, all the change cases that we might have, and then think about, okay, because we can't just judge that, okay, based on this change case, my alterability is good, but based on the other change case, my alterability is bad. We can't do that because overall, our design is the same, right? There's one same design. So when we look at alterability in this course here, we shouldn't be looking at how much new code we're going to add to our design, right? So what we're interested in is that how much changes we're going to make to the existing code. So adding new code does not mean that we're changing the existing code. Okay. So when we look at alterability, we want to look at how much changes we are making to our existing code. But what do we mean by new code? Okay. So for new code, if we add code to existing line, that means that we are actually changing our existing code. Right? We're changing our existing code base. So that's not new code. So things like if we're going to change my we're going to add some code to my existing method, then again, it's not adding new code. So adding new code would be something like we're going to create a new enum. So we can think of, so we're going to assume that when we create a class, each class will be in a new file. Right? So ideally that when we, in Java, when we implement the color game, for example, that each class should be in a new file. So when I add a new enum, that should be in a new class. If it's in a new file, then that's new code. So similarly, if I create a new interface, so we're adding a new file in addition to our existing code base. So that's a new file. So that's new code, and same with a new class. Okay, so when we assess alterability of our design, we should ignore the new files that we created, because we're interested. So if I'm gonna implement this change case, so we need to look at how much of the existing files that I have will be changed. So as we mentioned before the break, that this isn't really a model for alterability. So in this course here, we're going to make one ourselves. So we're going to look at what we call a change ratio. So here is the change ratio. Oops. Oh, well, highlighted by mistake. So here's a change ratio. So the change ratio is essentially this formula here. So we're going to look at in terms of a given change case with the impact I. So do we remember what impact is?
Yeah.
Yep. Good. So impact essentially how much we're willing to, essentially it's judged by us when we look at the requirement of how much we are willing to pay for making the change, right? So we're going to look at the change ratio based with respect to the impact that we have. So we have the number of classes of the existing design, N. So that's the number of files that we have in our existing code. And then C means that the changes that we need to make per class. So how many classes will need to be changed in order to implement the change case that we're interested in. And then we look at the change ratio with respect to the impact. So if my change ratio is similar to the impact, that means that while the cost of implementing this change case is about what we expect. So maybe it's okay in terms of alterability. However, if my change ratio, so I have many classes that needs to be changed, and that's greater than the impact we expect, then that means that while it's too high, so that means that maybe the alterability is not that great. And if the ratio is lower than the impact, then it's a better alterability. So what we like to aim for is that probably we want to aim for the change ratio that's lower than the impact, because that means that while with this change case, I only have to make few places, or I only need to change few places, and that's lower than what I expect the cost would be. So therefore that, okay, it's good, so it's higher alterability. We don't want the change ratio to be greater than the impact. That means that it could cost too much. And this is okay, right, when it's around the same. And given that we're going to have many different change cases for our design, so how do we assess? We can't really go about to look at, all the change cases and then look at the change ratio. And it's actually not doable, right? It's not possible that we're trying to figure out all the possible change cases and then assess the alterability. So what we want to focus on is that when we look at alterability, we want to focus on, as we said before the break, we want to look at those that have high likelihood and high impact. to assess the alterability, right? To look at the change ratio and the alterability of our design. One thing you note, has anyone noticed any flaw, any weaknesses of this kind of model of assessing alterability?
So
yeah,
how can
Ash.
you quantify I?
I is, remember from before the break we say it's based on our judgment, so based on the developer, it's quite subjective.
Like how can we come up with a number which is like, we can compare to C by N?
See, how do you compare the I, you mean with the ratio? Well, remember from the break we say, well, I is kind of, we're hand waving, right? We kind of decide, okay, this may have this impact. So it's kind of coming from our judgment. Yeah.
Like suppose C is 1. On that 1, you can't differentiate it between, like, let's say changing one line of code in a file between changing 100 lines of code in the same file.
That's very good. That's correct. So I'll repeat what. So with the change case, the ratio, one thing you will note that C is that it's the number of classes that need to be changed with respect to that change case when we're implementing that change case. So if I have one simple line of change in one class, so that's actually C will still be 1 because we're changing one class, right? If I have, let's say, this different change, and that's 100 lines, like I need to change many lines in that class, again, there's still C is equal to 1. So it's really not, like, so if you think about, I think we kind of mentioned this earlier as well, is that if, let's say that if I have a design where I only need to change one line of code across 5 different classes, my C will be 5, right? Versus if I have to change 100 lines, like a very complex change in one class, my C is 1. Based on the change ratio, that means that while that second case seems to have better alterability than the first one, assuming N is the same, right? Because the first case, it's the ratio is higher. So it is difficult to determine, okay, so if I have this case here, if I have a simple change across multiple files versus complex change versus one in one class, then how do we use the change ratio to justify the alterability of my design? Right. So that's one weakness of this model here. But given that there's no other models that we could look at to talk, I think this is still a good way for us to think about the changes that we're going to make and think about how it might affect our decisions when we design our code. Yeah, Harsh.
So the lines of code gets adding or changing is like the impact of the change, right?
The line, no. So C, impact is the change case, the impact of the change case.
Yeah, but usually if you're writing more lines, it's more higher impact.
If we write more lines, it's high impact. No. I would say you want to think about with respect to the requirement of the system, like what are we trying to build, right? And then you look at the overall, not just by line. I guess maybe by line is a good way of thinking about would this be a high impact or not. Yeah. Okay. So as a consequence of looking at the change ratio, so while we want to have as low as possible, right, with our change ratio, so that means that if we have a change case with low impact that requires every class to change at high C, it means it's lower alterability. So we want to reduce our change ratio as much as possible. So there are 2 ways of looking at this. So we could basically make N bigger. So we want to increase the number of classes that we have in our existing design. And then assuming that C doesn't increase at the same rate, the higher N is, the smaller our ratio is, right? So that means that we're going to have better alterability. The other thing is that then we want to look at reducing the number of classes, right? Reduce C will also lower, assuming N is the same, then we want to make sure we want to reduce the number of changes we're going to make per class. Number of classes, we want to reduce the number of classes we're going to change. Okay, so one thing to know with the change ratio is that when we calculate our change ratio, C does not include any new classes that we create. So when we assess our alterability, remember what I said earlier on, we don't include the new classes, right? So C is only the number of classes we're going to change from the existing design, right? So if I add new classes to my design, it does not come into the change ratio. Okay. Yeah.
How about if I separate one existing class into two existing class?
So if you separate your existing class to two classes, then you're increasing N, right?
Yeah.
So you're changing the existing class into two. So that's then you adding N.
How about C?
C, it's a good change, good question. So note that change ratio doesn't like cover everything. So if I have an existing class, I split into two classes. So two new classes. What does it mean? So I have one new class, and the other class is changed. So C is 1, isn't it? Because I'm creating a new class. Remember, creating a new class, a new file, it doesn't include. It's adding new class, it's not existing. But that's a good point. So what if I delete my class? Yeah. What if I delete my class? Yeah.
I think the number of class would decrease, but also the number of change will also increase because of the changing.
So with N, so the total number of classes will reduce, but the change will increase because we're changing. Yeah, Nick.
But if you're just adding classes pointlessly, then you're just cheating the system.
If we're adding classes, then we're just cheating the system. Well, but the thing is that new class doesn't count for any existing design. But yeah, that's the point, right? So how do we? So notice there's a flaw with this model. Is that it doesn't capture. First of all, it doesn't capture if I have a simple change versus complicated change, and as well as if I delete a class. What is it? I'll say it's a change, but N shouldn't change for now. It's existing, right? We're looking at the existing design first.
So in that case, if I add new classes, my N won't increase?
If you add new classes, N won't increase. For this change case, the thing is, notice that we are assessing based on the change case, right? For the next new change case, if I already have a new class added, and I'm assessing the alterability of the design again, then my N will increase, right? So note that this is assessing against the change case. Yeah.
So you said that the class will not affect the number of total class of existing out there.
Deleting. That's a good point. Maybe I should go and ask Ewan because he came up with this. That we actually, now I think we actually didn't encounter the deleting part. So what happens when we delete N? One class. What happens to the N? But if you look at here, N is the number of classes for our existing design. So if we're gonna delete one, we haven't made the change yet. We're just assessing, right? Looking at the change ratio. So I think I would say N is still the same, but C will increase by 1, as you mentioned. Yeah.
Technically speaking, like if we remove a class, that means like the highest like change ratio could be is just equals to like n minus 1 over n. You can't go any higher than that. So technically speaking, we're just minus 1 and it'll be completely okay.
N minus, yeah. Yeah, okay. Oh, by the way, like, given this ratio here, now, if I do n minus 1 and c remains 1, does that mean that my change ratio is now worse? So does it mean that we shouldn't delete our class?
Yeah.
So see, yeah, there's another flaw of this model, right?
If you're reducing n by 1 and the change ratio is greater, so that means the alterability is worse.
Yes.
So that makes sense.
Yeah.
Because
Yeah.
you're deleting an entire class.
Yeah. So that's the question I like. Yeah. So thinking about the consequences as well. I like this discussion. Maybe I should make this a test question too.
Most of the time,
Yeah.
the factoring, we will delete our classes.
So the comment is most of the time when we refactor our design, we'll be deleting classes. Is that true? How many of you delete classes when you refactor? Good, good. Couple of you.
I'm moving a few things around.
How many of you are actually adding more classes when you refactor? Not really.
Also,
Yeah. So I think adding more classes versus deleting. So this is a good question. Maybe I should post this on Ed discussion. We have a more discussion around what happens when we delete. But looking at the change ratio, but we're thinking about when we implement a new feature, a change case, then a lot of time we'll be adding more stuff to it, right? Adding more code to our existing design. Then I think this kind of gives us a good overview, not a good overview, but like kind of from a overview point that it kind of gives us an idea of, okay, so if I make this change and I have multiple places, is my design alterable? It's kind of give us a good, some way to explain what's going on. So, but coming back to the change ratio, so based on what we all said, that if we have n bigger than n, sorry, like if you guys want to talk, we can talk after class. Okay. The goal is that we want to lower the change ratio, and to do that, I think as Hash and Nick and everyone else said, that if we have, our goal is to reduce C, right? So that means that making fewer changes as we can, which this means it's consistent with what Bess and Clemens and Kesman's definition of that we want to minimize the number of elements when we change our code. So here's an example of a way we could look at using change ratio. So noughts and crosses, this question came up in the test. We want to change uppercase x to lowercase x and 0 to O. What is the maintenance activity? Oh, you guys will know the answer when I give you the test mark back. Okay, so the impact of this, we say that it's a 0.05. So there are two designs we have. So the first design is that we have noughts and crosses and grids. We have two classes in this design. So n is 2. And to make this change, we need to change one class. So C is 1, so that means our change ratio is 0.5. However, it's greater than the impact, so it's not that great. So that means that this change case, the change ratio for this change case is not alterable. Then we have another class, another design B, where we have 3 classes now. So in addition to the 2 classes, we have a mark class that specifies what gets printed for the 2-player. So n equals to 3, and for this change case, we only need to change one class. So again, C is 1, and the change ratio is 1/3. So feels like the ratio 0.33 is better than design A. Design B is better than design A in terms of the change ratio, right? So design B is more alterable than design A for this change case. However, you note that the impact is still really high. Sorry, the change ratio for both is higher than the impact. Okay. So there's an example use. So what can we do with change ratio? Well, we know that we are assessing the change ratio based on the change cases. And I think I already mentioned that because there are many change cases that we have, we can't go to assess each change ratio for each change case. It's not feasible. So what we like to look at is if we are making some design decisions and want to decide like which design we should follow, we want to basically look for designs that will minimize the change ratio, right? And also we want to focus on the change cases that's of high likelihood and high impact, because there's no point of looking at change cases that's not likely to happen, right? That's waste of your time. If it's not going to happen, why do we bother to trying to come up with a design that's going to have a good alterability for that change case? So when we want to look at making decisions, then we want to focus on those with high likelihood and high impact change cases. And also we can avoid designs where then what this means that for the remaining of this lecture, we're going to look at design patterns and how the advice given to us will help us to improve alterability, and looking at with respect to the change ratio. So, anyone not know about design patterns? So I'm looking at people who did PG Cert. Like if you say you don't know, then I'll be very sad. Design patterns. Everyone knows design patterns? Cool. Yep. Everyone loves design patterns? Nope. Okay, so design patterns. So I think this is where the design patterns come from. It's by the Gang of Four, by the 4 authors listed here. Basically, a design pattern, just a definition of a design pattern, is a general solution to a commonly occurring problem within a given context in software design. So when we look at design patterns, we know that it is for general solution. So it is not for a specific implementation, right? So we could have variations with the design patterns. And it is a solution that means there's no alternative, and it is used for specific contexts. You can't randomly use design patterns in the context that's different from what's been defined. So by definition, it does not support alterability, but you'll find that a lot of the times that with design patterns, it helps us to improve the alterability of our design. So that's if you're interested, I strongly encourage you to have a look at this book as well. They defines, I think, 27 design patterns. So one thing to note that with design patterns, we don't come up with our own design patterns. We don't invent our own design patterns, because design patterns are solution that's commonly known and that's being tested by other developers, the experts. Yeah. So with design patterns, how do we determine the design quality using the concept of design? So you'll find that some of the arguments you'll see online is that if you use design patterns, that means you have good design. That's actually the incorrect argument. So you don't use design patterns for the sake of design patterns, okay? So you want to use design patterns when you see a problem that could be solved, that's a commonly occurring problem, and you could apply design pattern to help you solve that problem, okay? So it doesn't mean that if you implement design patterns in every single application, it means that you have a good design. Okay? So you need to make sure that you apply design pattern in the right context. Okay, so we're gonna have 15 minutes to look at composite patterns. So everyone know composite pattern already? In 230, good. In COMPSCI 230, anyone else? Is anyone's first time seeing 018? So good. So composite pattern. Well, I think this is usually the first pattern you see when people talk about design patterns. So it captures nicely of the use of polymorphism. So without polymorphism, you can't really achieve composite pattern. But let's have a look at what composite pattern does. So here we have the intention of composite pattern is basically allows us to represent if you have a tree structure in your design, then you use composite pattern. So the goal is that we want to treat the individual objects and the compositions of the objects uniformly. So we want to treat the leaf and the composite the same. So the solution is with composite pattern, we have 3 elements. We have the component. So, sorry, I'm not sure, can't really see this. So here is a design where we have the component that represents the part and the whole, and usually it's an abstract class or interface. And then we have the leaf that represents the part, the simple. So you could think of the leaf is the individual object, and the composite will be the group of objects. And then we have the composite class here. So when the client interacts with my objects, it sees that either the individual and the group's the same. So they treat it the same way. That's the goal of composite. So you'll find variations of this. So here with this class diagram, so we got this class diagram from this URL here, but I don't think it's no longer available. But I think Wikipedia still uses this diagram. Kind of nicely captures of the differences of the two. So with a composite pattern, we could have 2 variations. So we have, if we want to design for uniformity, that means that the client treats the component, so the client treats the leaf and the composite the same way. Okay, so you'll find that with the component, you have the set of methods here, and the composite has the same set of methods here, right? So for example, the component has the add method, and the composite the composite object also has the add method. I forgot to mention that this is the relationship here with the aggregation part. So a composite object has a list of components, right? Because you could think of composite as a group. It has group of components. So that's to design for uniformity, you'll find that both the component and the composite has the same set of methods, so that when the client interacts, doesn't matter. So it knows that it has all these methods available for the client to interact with. If we want to design for type safety, then you'll find that the main difference is here in the composite, where the composite object has set of methods that's not available in the component. So you can think of, for example, with a file directory. So think file directory, yeah. With a file directory system, a file could be a leaf, a component, and the directory is the composite, right, where a directory can have a list of directories and files, right? And then a directory can add a file or add a directory. So if I want to make sure I design for type safety, then I know that with my directory can add a file or a directory, but a file shouldn't. So to do that, then we want to have the list of methods. So the composite will have the specific operations associated with the group. Okay. Questions about composite? So example, so I already mentioned we have the file systems, and we can also, if we have employee hierarchies, we can use composite pattern. Things like swing you might seen before that uses composite pattern. For example, arithmetic expressions where we could have the values and variables as the leaves and the expressions as the composite. So let's have a look at applying a composite pattern to our file system, our file directory structure. So here we have a file interface. So this would be the component. So this is the component. And then we have the plain file implements a file. So what I find it useful is I often would draw this on using a class diagram, a quick shorthand. So I have the file interface. So I'll just do it here. So it's an interface, not a file. And then we have the plain file that implements the file. And I also have the directory that also implement the file. Right? So the plain file is a leaf, right? So it's just a simple file, and the directory is actually the composite, where you'll find that usually with a composite pattern, it has a list of the component stored as part of the composite object. So here we have something like this. It's probably a unidirection. Yeah. So that's the structure, yeah, of the composite pattern. And then you'll find that when we add a file, for example, in my directory, we're adding regardless, it's a type of file, whether it's a directory or file, we don't know. Whether it's a directory or a plain file, we don't know. We just simply add that file object to the list of contents. And then when we print out the details, we go through the content, the list of content, right? So this is the composite, and the plain file is the leaf. So how we use this? So here is an example where we could. Here's a main method. We're in the browser class. So we can add a new directory here, create a root directory, and then we can add a simple plain file, one file, or we can also create another directory and add to the file. And then we can continue. And here, once we've created all the file directory, then what we can do is we can print the information out, right? So we can call a print method, where here we have a print method here. And then you'll find that doesn't matter whether it's a directory or not. It's just a file type. So the client, so this browser is the client. The client is interacting with the composite pattern. Is just printing out the information about the given file object, and then whether it's a directory or a plain file, it's when we run the program, you'll figure out, right? So that's the use of composite. So the idea is that we want to treat the composite and the component the same, right? Same way. So if I were to do this without using a composite pattern, this will be very long and probably will go out of this page here. So we're not going to show you, but it's going to be more complicated. And we'll probably have more files, right? Or like how we print out each individual detail. So when we think about design patterns, one of the things, so what are some of the benefits you can think of when we apply design patterns in terms of maintainability? Yeah.
So you only have to change this one file, because if you want to add like more components, it's new.
Yes.
New files. So
yeah.
The only change file is this one.
Yes, that's correct. So we're jumping on it, but good. So the comment is that if I were to create a new type of file, whether it's a new leaf or new type of composite, what I need to do is I just need to create that actual concrete. So I created the classes. I can just create a new concrete object, and I can just add the new type of files into the main method. That's the only place I need to change. I don't need to change the print method, right? Because I'm still dealing with file type, right? It's still it's still a subtype of file, right? So that's good. But the other benefits, let's say, since everyone knows composite pattern, so next time when Yu-Chen sees you and say, oh, in color, we're gonna do composite pattern, all of you say, yes, I know what composite pattern is, right? Right? We can do it. Okay, people don't seem that excited. We can do it. So that means that if we know the design patterns, like such as composite pattern, that's already in our knowledge base. So that means that it's more efficient. Good. It's more efficient that we know what composite pattern is. We don't need to go through the external representation because we both share the same vocabulary. My understanding of composite pattern should be the same as your understanding of composite pattern. So that means that it could help us to, next time when we see something similar applied, then we know that, oh, this is a composite pattern, right? So it helps us with comprehensibility. So in terms of observability, as earlier comment, so it means that, remember for our change ratio, so if we want to add a new type of file or new type of directory, then we just simply add a new class, right? And add a new class does not contribute to the change ratio, right? It's a new class, but we probably need to change maybe one class that help us to create that actual concrete object. So that means that C is 1, and then probably everything else stay the same. So and then similarly, it's adding if we add a new composite, it's the same, right? So we only need to have one class that needs to change. So C is 1. So seems like could be not bad with our composite pattern. Okay. So one thing to note, and it's quite important in your assignment as well, when you apply the design pattern. So you'll see that with the example here, we didn't have any interface or classes that's called component, right? So the component is actually the role the role in that design pattern. When we implement our game, we don't have to name the classes based on the role, right? So in the example of the file directory, the component is named as file, right? It's not named as component. So you need to make sure that when you apply your design pattern, you need to make sure the name you choose should meet with should match our context schema as much as we can, right? Like, so that it improves comprehensibility. Similarly, we don't name anything that's like composite or leaf, and then also note that if we do when we apply our design pattern, if we did it in the right context, if we you'll find that it should, for example, that it should meet the intent of what we're trying to do with the design pattern. So here with the print method, it shows that we are treating the directory and the plain file uniformly. Okay. And here's a summary of if we compare looking at the example and the row. So the component is the file, the composite is the directory, leaf is plain file, and client is the browser class. So we look at one design pattern today. So tomorrow we're going to look at more design patterns. And similarly, maybe next week we'll look at more design patterns. Okay, any questions? Getting very excited about talking about design patterns.